Hello, my name is William Reed. This is my term project. So let's go ahead and get started. I'm gonna actually clear all of this out just to start off. So starting off, we've got all these modules: pandas, numpy, scipy, matplotlib, scikit-learn, and seaborn. So starting off with the first task, importing the data from the CSV. I wanted to only work with the columns that actually had the numbered or numerical data in them. So I started off by just defining a range for which columns to import into the data frame. And then I also wanted to only use a certain number of rows because being that there's like 250,000 rows, my computer could not quite handle that for testing and running this program over and over again. So I used a slice of rows that includes all three machine statuses so that I could obviously test them. So anyway, here we read the data into a data frame using all of the restraints that I defined, and then I just printed it to make sure that it works. So next step in the data cleaning, data pre-processing was handling null values because there was a lot of them, especially in column or in sensor 15's column, which at least in my slice or the rows I used had no values at all. So I ended up just dropping that column entirely. And then I checked again for null values to make sure that they were all gone, and they were. Next up, outliers. I use the z-score to calculate which values in each column were outliers from the other values in that column, since I noticed that each column with respect to other columns varied quite a lot, but within the same column I looked for outliers there to get rid of those. And then for standardizing the data, I noticed a lot of data had some trailing zeros or just different amounts of decimal places all over the place. So I just standardized all of them or I rounded all of them off at 5. And then, of course, after I did everything, I like to just print the data frame. So pre-processing out of the way, let's move on to the second task, which was exploratory data analysis. So I started off by plotting a histogram for all of the sensor columns. And actually, let me just go ahead and run this so I can pull that up. But at this point, I only had the numerical columns in the data frame, so I needed some way to get the machine statuses in so that I could compare it with the values. And here we go with the histogram. So it's all zoomed out, so I have a histogram of every sensor column. So here I loaded the machine status column on its own into a separate data frame, and I skipped the same rows that I skipped for the first data frame, so that obviously the machine statuses corresponded to the actual rows that I had in there. Next, I encoded the machine status column so that I could compare the values to a numerical set of values for the machine status instead of strings. And then I reset the index of both data frames so that I could then concatenate them into one instead of having mismatched indexes. So then I did that, concatenated them, and then I checked the status mapping of the machine status to the encoded version, which was a 0, 1, 2, 3. And actually, let's go down here. to, here we go. So status mapping, I'm not sure why it's now not including the broken one, but point being, status maps. And next we have, where am I? Task 3, feature engineering. So for this, again, I selected only the numeric columns because using the machine status string column was giving me an error. It's not comparable. And then I calculated the correlations between the sensor columns and the encoded status so that we could compare those. And then preparing data, split the data, initialize the random forest classifier, get feature importances, print the feature importances. Oh, here we go. Plot. So then I plotted it. Let's find that. Here we go. So after I got all of the feature importances of each individual sensor column, I plotted it out here. And there's a pretty clear distinction here. Sensor 3 having the most. And there's a pretty harsh drop off, obviously. But I like to present data a little visually rather than looking at the console for every piece of information. So task 4, predictive modeling. Define which columns contain numerical sensor data. Again, same thing. And then I split the data into training and testing sets. Initialize 3 different models, a logistic regression model, random forest classifier model, and then SVM model. So then trained the models, made the predictions, and then I defined a function to evaluate the model based on accuracy, precision, recall, and F1 score. And let's find that in the console. Where is... here we go. So we have the performance metrics down here for each one, displayed somewhat nicely. It could be displayed better, but so we have these here, and then task 5, model evaluation and selection. So obviously more or less the most important part. So I use stratified cross-validation, and I defined another function here to evaluate that. And then again, prepared the models. I use a dictionary for that. Dictionary to store the results, and then again, metrics, accuracy, precision, recall, and F1. And then I evaluated each model on those metrics. So if we go down to, where did I print it? Oh, okay, all the way at the bottom here. There we go. So we've got accuracy, precision, recall, F1 for each of the 3 models. Now, accuracy, random forest had the best. Precision, random forest had the best. Recall, random forest had the best. F1, random forest had the best. So obviously, my selection was that the random forest model did perform the best out of the 3. And in second was logistic regression, and last was SVM. So overall, I would say this project definitely learned a lot from it, especially a lot of things with Python that I've never done in a lot of data structures classes and things like that, where working with data, it was definitely a little bit different. I liked it. It was a good, different way to use Python. And especially all these libraries. Pandas mainly for data manipulation and things like that is, and throughout the whole course, but it definitely was a new way to do things that I can take into general tasks or future classes or future jobs. So I enjoyed this project.